My duty is to make you love mathematics. Now, welcome and let's do what we have for today together. Now, we are discussing still on differentiation. In today's class, you are going to learn how to use the quotient rule and the chain rule in your differentiation. Now, remember we've already talked about the quotient rule and the chain rule. The links I will leave in the comments. So let's see how to combine them in a question. And how do I know a question that requires quotient and chain rule? Now, when we look at this function, this is what we are asked to differentiate. We are given f of x to find f prime of x. When you see this, it means to differentiate this function once. Okay? So what you are to do, if you look at this function, you will notice that this function is in a ratio form. When you have a function in a ratio form like this, you are to make use of your quotient because quotient is gotten by division. Okay, so it means you are to use quotient rule. And why are we also using chain rule? We are to use chain rule because when you look at this denominator, you notice that the function is in a radical form. And we said it that if functions are in radical or root forms, you use your chain rule. I hope you now know the reason. Now, let's go into solving proper. Now, if this is a function of u of x as given like this, if you're using your quotient rule, then we say that our dy dx is equal to v du or du dx minus u dv or dv dx all over v squared. So this is your formula for quotient rule. And it's quotient rule that is the key rule to use here. Okay, so let's go into solving proper. Now, let's identify our u and x and v. Our u is the first function, the numerator. So if our u is 3 plus 2x minus x squared, then can we get our du? Du is also same as du dx, okay? So if you want to have your du will now be to differentiate this using your power rule, okay? Always use your power rule. The link I will also leave in the comments. So if this is your function, for power rule, dy dx is nx, use the power to multiply, then take 1 from the power. So this is for your power rule, okay? Now let's apply it here. To get our du or du dx, when you differentiate 3 is a constant, it gives you 0. Now when you have 2x, it's same as 2x to the power of 1. So use it to multiply 2. 1 multiplies 2 will give us 2. You return your x, take 1 from the power, and 1 minus 1 will give us 0. So x raised to power 0, according to your indices, is 1. So you have 2 times 1, it will give you 2. Okay, so you are free to write only 2 here. I hope you can say that. Then we have minus, use this to multiply. We have 2x, take 1 from here, 2 minus 1 will give us 1. And in your indices, x to the power of 1 is x. So you're also free to take off your power 1. So this is what you have. And if you add this, it will still give us 2 minus 2x. So this is for our du. Now let's go to our v. Our v is given as the root of 1 plus x. Now when you have this function, like we said, it is now 2 functions in 1. So you use your chain rule. Okay, but before then, this function can also be written as 1 plus x to the power of, this root is written in index form to become 1 over 2. Okay, this is what this means in index form. Now, in differentiating this using chain rule, identify the inside function. The inside is the one inside the bracket. So we have our inside function to be 1 plus x. Okay, now if you now want to get your dv or your dv dx, is going to be differentiate the outside. The outside is the one outside the bracket, and that will give us, use the power to multiply. So we have half bracket, return this, don't touch it, okay? So we have 1 plus x. Then take 1 from the power using the power rule. Half minus 1 will give us negative half. I hope you are there. Now, multiply by the differentiation of the inside. For the inside, we have, if you differentiate 1 is 0. If you differentiate x, x is having a power of 1. So if you use 1 to multiply it, it will give you 1 x. Then take 1 from here, we have 0. And x to the power of 0 is 1. And 1 times 1 will give you 1. So when you differentiate x, you get 1. I hope that is clear. So let's simplify now to half. Our dv is half into 1 plus x multiplying 0 plus 1 will give us 1. And when you multiply this by 1, it gives you half into 1 plus x. And this, let's take our power raised to power of negative half. I hope that is clear. So this has become our dv dx. Now that we have gotten these two, let's plug them into this function, this formula of quotient rule. Now we can do that and complete. Remember, if you are still new to this channel, don't forget to subscribe for us for more are coming, and give this tutorial a thumbs up. Let's know your thoughts about this in the comment section. You can share with your friends and colleagues. Now let's continue. To continue with this, we are going to plug in this into this statement here. And if you do that, we are going to have, this is going to give us dy dx. Let's take this off. Our dy dx will be equal to, your v is the denominator, which is 1 plus x. Let's express it in index form like we did here. In index form, we got this raised to power of half, okay? So this is the same as this, and that is our v. Then our du is what? What did we get as du? Our du is 2 minus 2x. So we have 2 minus 2x. We are going to put it in bracket because it's an expression, okay? Then minus, I can take this part off, minus our u is what? Our u is the numerator, which is 3 plus 2x minus x squared. This is an expression, put it in brackets, okay? Then your dv, as we have gotten our dv as this. So you can take this off so that you write your dv as half is multiplying 1 plus x to the power of negative half. Then all this will be divided by what? By v, and our v is 1 plus x to the power of half, or you can still return it as square root of this, then raise it to the power of 2. Did you see that? Your v squared, this is your v, then we are raising it to the power of 2. So at this point, we have been able to do substitution. What you need to do next is now to simplify, okay? Simplify as much as you can. Remember, this can cancel this, okay? Now at this, you will notice that these are separate expressions. These are separate ones, which are separated with this operation. So we're going to factor out what is common in these two sides of the expression. So what is common? You will notice 1 plus x is here and here. So you are going to choose the one that has a lesser power. So in that case, you are going to have, let's choose this one because it has lesser. So we have 1 plus x is raised to the power of half, okay? Then open up a big bracket. If you do that, you are going to factor out. So we have factored this out. Use this you factored out to divide this side of the expression. So if you do that, see what we get. If you do that, you are going to have this is what we have, 1 plus x to the power of half multiplied by 2 minus 2x divided by what you factored out raised to the power of negative half. In your indices, x to the power of m over x to the power of n is x to the power of m you subtract, okay? This is your indices. So in that case, for this, supposing this has a negative, if it has a negative, it means we are going to have x to the power of m. The subtraction will affect this, so we have plus n. I hope that is clear. So if you are simplifying this, you are going to now have, this will give you this will give us 1 plus x to the power of half, and this will become plus half, okay, because it's negative. Then we multiply our result by 2 minus 2x. Half plus half will give us 1. So we have 1 plus x to the power of 1, and anything raised to power 1 is that number. So we can have this into 2 minus 2x. Okay, so for factoring out this and dividing this with this, we are having 1 plus x and 2 minus 2x. Okay, that's what we got. Return your subtraction sign. Then use this to also divide this side of the expression. And if you do that, see what you get. You're going to now have 3 plus 2x minus x squared multiplied by half into 1 plus x to the power of half divided by this value you factored out. Okay, you will notice that this, we have to cancel this. So in that case, you are going to be left with half bracket 3 plus 2x minus x squared. Okay, so this is what we have. At this point, remember, you are still left with this denominator, which is 1 plus x. Okay, so we can now conclude to have 1 plus x to the power of negative half. If you expand this, it is going to give you 2 minus 2x squared. Expand this, you are going to have negative 3 over 2 minus x plus x squared over 2. Okay, all over 1 plus x. Now you can conclude to have, because of this negative, this expression will come down. So if simplifying this inside is going to give us 2, the denominator is 2, so we multiply each, we multiply by 2, you have 4 minus 4x squared minus 3 minus 2x plus x squared all over 2. Okay, then divided by 1 plus x is multiplying 1 plus x to the power of half. So if you simplify finally, your dy dx is going to give you dy dx is equal to 4, subtract this, we are going to have 4 minus 3 is 1. Then we have negative 2x. This will give us negative 3x squared all over. This will have to come down. So we have 2 into 1 plus x. They are multiplying. The power here is 1. So if you add the power, it gives you 3 over 2. And this is what you get for differentiating this particular function. I hope you learned a lot. If you did, don't forget to give this tutorial a thumbs up. Let's know your thoughts in the comment section. Share this and subscribe us for more. I will see you next. Bye-bye.